Hey guys, so we started yesterday with just by looking at key features of quadratics. So again, quadratics, they make parabolas when we graph them, that beautiful U shape, so they're nice and symmetrical. Sometimes they have x-intercepts, sometimes there's there's always a vertex. There's an axis of symmetry. So I want us to be able to graph quadratics, but before we can do that, there's a few important things that we need to be able to figure out. So the first we're going to start off is solving quadratics by factoring. There's a couple different methods you can use. So notice in my toolbox I have GCF, grouping, and modeling. So we're going to start by using something that might look a little familiar, GCF. Do you remember what GCF stands for? Hopefully you guessed. That's the greatest common factor. So when I go to factor, and notice I have a binomial, and a trinomial. So this works for anything. First thing we like to do is we like to look and see, is there a GCF? Is there a greatest common factor? It's going to look a little different because we have variables involved, but don't get scared. Okay, we got this. So when I look, I have 6a squared plus 27. What's my GCF here? Well, first I'm going to start with my numbers. So I have a coefficient of 6, I have a constant of 27. So 6 and 27, what goes into both? Well, I'm going to take my smaller number 6. What are the factors of 6? 1, technically, 2, and 3. Okay, so 6 and 27. Nope, 2 doesn't go into it. Oh, 6 and 27, 3 does. So I know that nothing bigger will go in because it wouldn't go into the 6. So I have a 3. Now this term has a squared. Does this term have any a's? No. So the only thing that we can factor out is a 3. So if we factor out 3, what's left? So 6a squared divided by 3. What's 6 divided by 3? 2. A squared, well, just bring it down. So we have 2a squared plus 27 divided by 3, 9. Now the nice things about these is they're super easy to check. So all we need to do is we have this 3, we just distribute the 3. So what's 3 times 2a squared? 3 times 2, 6, a squared. 3 times positive 9, positive 27. So these are quick and easy to check. That is all it is when it comes to factored form. If I'm looking for a GCF, that's all that I can do for this particular problem. So greatest common factor is just a 3. So let's look at 15a squared b minus 30ab. Okay, so this has got a little bit more going on. First, I'm going to start with my coefficients. So 15 and 30. What goes into, well, and technically negative 30. What goes into both? So I look at my smaller number, factors of 15. 1 and 15. 3 and 5. So what goes into 15 and 30? 3, yes. 5, yes. 15, yes. All right, so they both have a factor of 15. Cool beans. I'm going to take that out. Now let's look at our variables. So one at a time. A squared and an a. I'm going to put in my invisible ones to all my terms. So this first term has 2 a's. My second term has 1 a. So how many can I borrow? Well, I can only borrow the minimum because this term doesn't have 2 to give. So we can only borrow 1. All right, now what about the b's? 1b, 1b, cool. Both terms have 1b to give. So if we factor those out, what's left? Well, one thing at a time. 15 divided by 15, 1. You can write the 1, but you don't have to. A squared divided by a. So again, a squared divided by a to the first. So we would subtract. We're left with 1a. B to the first. B to the first. B divided by b. Nothing's left. Cancel out. All right. So now let's look at negative 30. So negative 30 divided by 15. Negative 2. A divided by a. Again, same thing. Cancels out. B divided by b. Those cancel out. So I'm just left with an a minus 2. Again, if you're wanting to check, just distribute. So 15ab times a. 15, just 15. a times a squared, and a b. 15 times negative 2, negative 30, and we've got the a and the b covered. So this is our factored form. Factored forms help us to find the zeros of our graph. Those zeros are the x-intercepts. So there is a purpose why we're going to learn how to do this. All right, last one. If you think you can tackle this, go ahead and pause the video and then pick up when you're ready. All right, so 6y to the fourth plus 14y cubed minus 10y squared. Whew. Okay, so first, let's look at the coefficients. 6, 14, and 10. So I'm going to go to my smallest coefficient, which is 6. So factors are 1, 2, 3, and 6. So 1, obviously, 1 goes into everything. 2, 6, 14, 10, yep, 2 goes into all of those. 3, 3 doesn't go into 14. 6 still doesn't go into 14. So I think the largest coefficient, 2. So we're going to factor out a 2. Now let's look at our variables. Y to the fourth, y cubed, and a y squared. All right, so what is the minimum number of y's we have? Because remember, I can't borrow more than I have. So our first term has 4 y's, 3 y's, 2 y's, so we can borrow 2 y's because every term has at least 2 y's. All right, now let's see what's left when we factor or when we divide. So 6 divided by 2 is 3. Y to the fourth divided by y squared. 4 minus 2 is 2 left over. All right, positive 14y cubed. Positive 14 divided by 2. Positive 7. Y cubed divided by y squared. I have 3. I'm taking 2. I got 1 left. And then negative 10y squared. So negative 10 divided by 2. Negative 5. Y squared divided by y squared cancels out. And we're done. Again, you can always check these. 2 times 3 is 6. Y squared times y squared, y to the fourth. 2 times 7, 14. Y squared times y to the first. 14y cubed. And 2 times negative 5, negative 10, y squared. Beautiful. Cool. All right. So these are factoring in the GCF, which is something we always want to look for, I guess, while we're factoring. But there are other things we need to do as well. So let's look at, I have 4 more examples. You can do these in any order, it doesn't matter. So what I'd like you to do is go ahead and pause the video, write down these 4 examples. Then I want you to come over here and just copy down these steps. So you can go ahead and pause the video now, unpause when you're ready, because I'm going to explain these steps as we try one of the problems. Okay, so let's come over here and let's pick a problem. I'm going to pick this blue just because I really like that color. Now I need to try and find a color that matches. Okay, that looks close. So 3n, don't make fun of me. 3n squared plus 5n equals negative 2. Love it. Good problem. Okay, so let's come over here. Step 0. Set it equal to 0. Okay. When we're setting equal to 0, we also need to make sure that these are in standard form. So to set this equal to 0, I need to move my positive 2 over with all my other terms. So I'm going to go ahead and add 2 to both sides. So I have 3n squared plus 5n plus 2 equals 0. Alrighty, so let's look. It says the next thing we're going to do, look for a GCF. Now, if you happen to skip this step, yes, you can still get the answers correct. However, if there is a GCF, if you take it out, it usually makes your terms the actual numbers, like the coefficients, it usually makes stuff easier to work with. So 3n squared plus 5n plus 2. Okay, so 3, 5, 2. Nope, no GCFs there. An n squared, an n, and another, nope, no more variables. So it doesn't have an n. So now in your best State Farm commercial voice, do the jingle, do the jingle. All right, so our jingle is A times C, sum of B, factor tree. I know that sounds silly, but it'll make sense in a minute. So A times C, sum of B, factor tree. Now, this is in standard form, A, B, C. So as long as this is written in descending order, so biggest or largest exponent first and going down, then your A, B, and C will be in order. So I usually always start by underline, underline, circle. Underline, underline, circle. So A times C, 3 times 2 is 6. Sum of B, so we need to find factors of 6 that are a sum of B, so a sum of positive 5. How do we do that? Factor tree. So factors of 6, 1 and 6, 2 and 3. Cool. So are any of these factors, would they have a sum of positive 5? Sure. 2 plus 3. Now, why did we do that, you ask? Well, I'm going to show you. Because right now we have a trinomial, so it's a little difficult to factor a trinomial. Now, if we want to take away the guessing game, we can do factor by grouping. I love factor by grouping, and you're going to see why in a second. So what I'm going to do is I'm going to keep my A term and my C term. So I'm going to keep my 3n squared, and I'm going to keep my positive 2. And what I'm going to do is I'm going to replace the B term, that positive 5n, with my two new factors. So positive 2 and a positive 3. But I'm replacing 5n, so I need to do plus 2n plus 3n. And then bring down your positive 2. Okay, so what I did, now why am I allowed to do that? Because it's equivalent. Is 2n plus 3n 5n? Heck yeah. So I just went from having 3 terms to 4 terms. Why? Well, if I do factor by grouping, so if I group my first 2 and I group my second 2, now we're going to use our GCF. So 3n squared, sorry, if you come over here, that's how I knew that. So we're going to write out our new polynomial and factor by grouping. So we're just going to use the GCF. 3n squared plus 2n, so 3 and 2. It's just a 1, doesn't really help us. However, n squared and n, what do both terms have? Yeah, they have an n. So if I factor out an n, what is left over? 3n plus 2. Cool? 3n squared divided by n, we borrowed one n, there's only one left. 2n, we borrowed that in, there's only a positive 2 left. Now, we need to factor this one as well, 3n plus 2. You must factor something. So 3n and positive 2, what's the GCF? Positive 1, like 3, 2, that's the only thing that goes into both. So I'm going to factor out a positive 1, but look at what's left. Just a 3n plus 2. Now, why I love factor by grouping. Because if you do factor by grouping correctly, these 2 inside the parentheses will always match. It's awesome. So what are our factors? N and a positive 1 and 3n plus 2. Now this did say, I think what was the title? Factoring and solving? Yeah, solving quadratic equations by factoring. So we're going to solve, we're going to find the solutions. Remember, technically this was set equal to 0. So we're going to set both of these equal to 0. And we're going to solve for n. So n plus 1, if I set it equal to 0, subtract 1, n equals negative 1. 3n plus 2, set it equal to 0. Subtract 2, 3n equals negative 2. Divide by 3, n equals negative 2/3. So my solutions are, well, I'm going to write out both actually. I'm going to write what my factored form is and then my solutions. So our factored form, n plus 1 and 3n plus 2. So if they ask you for factored form, you could have stopped there. If they ask you for solutions, our solutions are negative 1 and negative 2/3. So it just depends on what the question is asking you. Now, quadratics, notice highest power of 2, meaning it can have up to 2 solutions. So you can have 1 solution, 2 solutions, or no solution. Think about that graphically. We have a parabola, right? My parabola can hit the x-axis 1 time, 2 times, or no times. So hence where we're getting the 2 solutions, 1 solution, or no solutions. So that's just kind of a visual of how we get that many solutions. Cool? Are we ready to try another? All right. Let's see. How about 4w squared minus 120 equals 52w? That looks good. 4w squared minus 120 equals 52w. All right. So before you even start, you better be thinking of step 0. Gotta set equal to 0. So if we're gonna factor or solve, remember those solutions, those are x-intercepts, are zeros. All right, right now I have a red flag waving in my forehead going, hey, something's wrong. Yeah, we are not set equal to 0, so we must do that first. All right, so that's where I'm gonna start. I'm going to take this 52w and move it over with everything. So I'm going to positive 52w, I'm going to subtract 52w from both sides. And when I write it, I'm going to make sure that I put it in standard form. So 4w squared. And then my w, so minus 52w minus 120. All right, now that everything equals 0, now I can find my zeros, my solutions, my roots. Okay, so first, let's look for that GCF. 4, 52, 120. All right, so 4 and 120, 4 and 12, 4 goes into both. Does 4 go into 52? Yeah, it does. Okay, so I know I have a GCF of 4. W squared, W, no W. Okay, so just 4. All right, so if I'm going to factor out my 4, and what is left? So I've got a W squared, a negative 13w, and minus 30. Okay. So when I go to do the jingle, A times C, I'm already liking this. Like my numbers are already smaller, so that's making me happy. So, because before, if we would have just done the jingle, A times C, 4 times 120, big number, that would have been a lot of factoring. Whereas now I only have 1 times negative 30, so I'm only factoring negative 30. Much smaller. All right, so it's factors of negative 30 that give us negative 13. So I'm just going to list my factors real quick. 1 and 30, 2 and 15, 3 and 10, 4, no, 5, yes, 5 and 6. And if I go in order, 1, 2, 3, 4, 5, once I wrap around, so my next factor would be 6. As long as I've gone in order, I know I've listed them all. So now I want to look at this and say, okay, so factors of negative 30 that add up to be negative 13. Now, don't get caught, because I think a lot of people look at this and be like, oh yeah, 3 plus 10 is 13. Okay, but we're looking for negative 13. Okay, cool. Negative 3 plus negative 10 equals negative 13. You are correct. However, does negative 3 times negative 10 give us negative 30? No, that one does not work. It's actually 2 and 15. How can I take 2 and 15 to get a negative 13? 2 minus 15. Oh. And what's 2 times negative 15? Negative 30. So when you're factoring a negative number, if the b term is negative, then they're going to have opposite signs, because opposite signs when multiplying is the only way we'll get a negative. Okay, so I'm going to go ahead and write this out again. Now that 4 that we factored out in the beginning, it's pretty much useless for finding the solutions. It's useful for other things like graphing, but for right now we're really not going to use it, so I'm just going to drag it on down so I don't forget to write it at the end. Now, let's go ahead and create our new polynomial. So we got w squared, and then our 2 new terms. So let's replace that negative 13w with positive 2w and negative 15w. And don't forget to bring down the c term, negative 30. Okay, so whether you're doing factor by grouping or factor by modeling, everything up to this point is all of the same process. So I'm going to do one more with grouping, and then I'll show you a modeling. So with grouping, I need to, you guessed it, group. All right, so my first 2 terms, I've got a w squared and a positive 2w. My last 2 terms, negative 15w and a negative 30. Okay, so w squared plus 2w. What's my GCF? W squared plus 2w. Well, what do both terms have? A w. So if I factor out a w, what's left? Well, I had 2, I've borrowed 1, so I have 1 left. Positive 2w divided by w, positive 2. I already took the w's. Okay, and then negative 15w minus 30. So negative 15, negative 30, negative 15. So when I factor out a negative 15, negative 15w divided by negative 15 leaves us with w. Cool. Negative 30 divided by negative 15, positive 2. Guess what happened? Both of them match. Literally, this is like being able to check your work while you're doing your work. It's awesome. Now, if we would have only factored out a 15 and on a negative 15, we would have ended up with negative w minus 2. And they wouldn't have matched, so we would have known, okay, I need to look back again. Something's not quite right here. But we did, because we're awesome. So let's go ahead. What is our factored form? Okay, I guess I didn't need to bring the 4 down that far. So we got w minus 15. Those come together and make one factor. And then w plus 2. And again, that 4 that we factored in the beginning, we just tack it up front. So if we go to solve, remember, we're finding the solutions, we're finding our zeros, so we need to set it equal to 0. So this 4, I can just attach it with whichever factors we wrote first. It won't change the answer regardless. So 4 times w minus 15 equals 0. All right, so solve for w 4 times, so I'm going to divide by 4. 0 divided by 4, still 0. W minus 15 equals 0. Add 15. So one of my solutions is a positive 15. Okay, now let's find the other one. So w plus 2. Set it equal to 0. Subtract 2 from both sides. W equals negative 2. So our solutions and our factors. The factors were 4, w minus 15, and a w plus 2, which gave us solutions of -2 and +15. Sweet. Cool beans? So this is a very methodical process. So you're going to have to do 2 or 3 of these before they really start to sink in, okay? All right. Let's go ahead and pick another example. Again, if you're feeling comfortable, go ahead and pause this video and try them on your own. All right. So I'm going to go ahead and do this top one. X squared minus 12x plus 36 equals 0. Okay, so x squared minus 12x plus 36 equals 0. Cool beans. Okay, so step 0, set equal to 0. Check. All right, next step, GCF. X squared, negative 12x, positive 36. So this is really a 1. So 1, negative 12, 36, just 1. That's not helpful. X squared, x, no GCF. All right, so now underline, underline, and circle. Underline, underline, circle. So let's do the jingle. A times B. So we have 1 times 36. 36. And we want factors of 36 that'll give us a negative 12. So let's go ahead and factor. 1 and 36. I know it's funny that I write that, but you should be surprised sometimes. That's the one that gets people. They forget about that factor, and those are the ones that you need. So I always try and list them just to remind myself. All right, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Cool. And I went in order, so I'm back around to the right side, so I know I've listed them all. All right. So factors that have a positive 36 but add up to negative 12. How is that going to happen? Oh, what about 6 and 6? Do those give us 12? Yeah, but we need negative 12. We'll just make them negative. All right, so negative 6 and negative 6, that does add up to give us negative 12, and negative 6 times negative 6 gives us positive 36. Perfect. Okay, so factor by, well, whether we're using grouping or modeling, I'll show you guys modeling this time, we still have to go from 3 terms to 4. So it's the same process in the beginning. All right, so let's write it out. So I've got x squared what is happening with my pen? Okay, and then negative 6x, negative 6x, and positive 36. Okay, so I'm going to show you guys factor by modeling. Now, remember modeling when we multiplied? Okay, so it's that box method, but we're going to kind of do it in reverse. So I've got 4 terms. So I'm going to set up a 2 by 2 box. But instead of putting my terms on the outside, remember, factoring is kind of undoing that multiplication. So I'm going to put my terms on the inside. So x squared, and then minus 6x. And then my next 2 terms, minus 6x plus 36. And yes, I include the signs. So now we're just going to factor, but we're going to look at it, the factoring. We're going to go, you can go horizontally and then vertically, vertically and horizontally, doesn't matter. So I'm going to start vertically. So I've got x squared and negative 6x. So what's my GCF? Well, both terms, they have an x. So I'm going to take an x out. And then negative 6x plus 36. So what do they both have? 6? Okay. Or negative 6? I don't know. Shh. It could be either. Sorry, my dog is being neurotic tonight. All right, so x squared minus 6x. So again, they both have an x. And negative 6x and positive 36. So again, this is why I don't love modeling, because I'm not sure. Am I supposed to be factoring out a negative 6 or a positive 6? With grouping, there is no questions because those need to match. I think it's a negative 6, but I'm not sure. So to check my work, I would have to write this out. X minus 6, and so that's my top one, and then x and a minus 6. That's my one to the left. So the only way to check this would be to multiply. So x times x, x squared, negative 6x, negative 6x, and positive 36. Okay, so x squared minus 6x minus 6x, negative 12x, plus 36. Okay, so that does give us back to our original. So I did factor it right, but I had kind of a little guessing game there. Again, why modeling is not my favorite. I love factor by grouping simply because I know if I'm right while I'm doing my work. Again, if you want to do modeling, it's fine, but you're going to need to go back in the end and check real quick. All right, so we still haven't solved yet. So x minus 6 and an x minus 6. So what would make those equal to 0? Well, set them equal to 0. X minus 6 equals 0. Add 6. X equals 6. Wait a minute. Wouldn't that be the same thing for here? Yeah. So our solution is x equals 6. So this is one solution. So this is an example. That's not pretty. So if we were to graph this at where x equals 6, my parabola hits once. And my a term, come back to my original, my a term is positive, so my parabola would go up. Again, that's just a sketch, but this is one of the things that we're able to find once we find those solutions, the x-intercepts. So that's going to be a piece that'll help us graph later. All right, I would love for you to try this last one on your own. 16x squared minus 24x plus 8 equals 0. So I would love it if you would try this on your own, use those steps, and if you get stuck, then go ahead and come back, but try it on your own first. All right, 16x squared minus 24x plus 8 equals 0. Boom, set equal to 0. We're already on our way. All right, so do I want to go to the jingle? No. Oh, GCF. Yes, GCF. Definite. Gonna make my life easier. Okay, 16, negative 24, 8. Look at my smallest term, 8. Hey, does 8 go into 24? Yes, 16. Sweet. We have a GCF of 8. My last term does not have an x, so that's it. So if I factor out 8, this is going to make my numbers nice and easy, nice and small. So I've got 2x squared minus 3x plus 1. Awesome. That's so much smaller. Okay, so now let's do the jingle. Underline, underline, circle. So a times c, 2 times 1 is 2. Factors of 2, 1 and 2. Oh my gosh, that was such hard work. Uh-oh, but we need them to add up to negative 3. How do we do that again? Oh yeah, negative 1 and negative 2 gives us negative 3. Beautiful. All right, so I'm going to use factor by grouping because as you can tell, that is my fave. So I'm going to keep my first term, 2x squared. I'm going to replace negative 3x with my two new terms, negative 1x and negative 2x. And don't you forget down to bring down c, so plus 1. My beautiful 3 terms becomes 4, and now we can group it up. Okay, so 2x squared minus 1x, what is their GCF? 2 and negative 1. Just a 1, that doesn't help, but both terms do have an x. Sweet, so I'm going to factor out my x, and what's left? Well, I borrowed 1x, so I'm just left with 2x minus 1, because I factored out the x. Negative 2x plus 1. 2 and 1. Just 1 again. And this term doesn't have an x. What the heck? Wait a minute. Don't forget, we want what's in our parentheses to match. They don't match yet, but what can I do? I can take out, because I want it to be a positive 2x. So what do I got to do to make that a positive 2x? Well, I'm going to divide by negative 1. And when we do that, negative 2x divided by negative 1, 2x. 1 divided by negative 1, negative 1. And we match, so we're right. Amazing. So, factored form, x minus 1. And I'm just going to go ahead and set it equal to 0 since we're solving. And 2x minus 1. And I'm going to set it equal to 0. Home stretch, just solve. Easy peasy. Add 1. X equals 1. 2x minus 1. Oh, same thing. Add 1. But 2x equals 1. Divide by 2. X equals 1/2. So our solutions, 1 and 1/2. If they ask for the factors, 2x minus 1 and x minus 1. Okay, so it just depends on the question whether they're going to ask you for factored form or to find the solutions. So we'll just go ahead. Once we have factors, we can find those solutions super easy. Just pay attention to directions so you don't do more work than you have to. All right, take a breather. Then I want you guys to try some on your own. See if you can figure out that jingle, make that stuff make sense for you. All right, let me know if you have questions.